One of the goals of organic chemistry is to synthesize complex carbon compounds from simpler compounds. One way of doing this is to use Grignard reactions. Your starting material is an alkyl halide, that is, an alkane with a hydrogen substituted for a halogen, often bromine. Adding magnesium and ether to the alkyl bromide produces an alkyl magnesium bromide, where the magnesium atom is bonded to both the bromine and the rest of the molecule. This Grignard reagent, as it is known, will react with carbonyl compounds containing a carbon-oxygen double bond, to produce alcohols following an aqueous acid workup. The type of carbonyl compound used affects the structure of the products. If formaldehyde is used, a primary alcohol, where the carbon bonded to the hydroxyl group is bonded to just one other carbon, is formed. If other aldehydes are used, we see a secondary alcohol formed, where the carbon is bonded to a hydroxyl group and to two other carbons. If a ketone is used, we see a tertiary alcohol formed, where the carbon is bonded to a hydroxyl group and three other carbons. The mechanism shows a two-step reaction. First, the slightly positive magnesium forms a bond with the oxygen of the carbonyl group, while the slightly negative attached carbon bonds to the carbon of the carbonyl group. In the next step, hydrolysis from water occurs, where the acidic proton bonds to the oxygen, displacing the magnesium, which simultaneously bonds with the remaining hydroxide ion from the protonated water. Let's show a simple example. Methyl magnesium bromide reacts with formaldehyde. Formaldehyde produces a primary alcohol, and we see the final products would have two carbons, so ethanol is the product. What if we replace formaldehyde with acetaldehyde, also known as ethanal? Well, the aldehyde must produce a secondary alcohol, and the methyl group will attach to the carbon on the carbonyl group, so the product is 2-propanol, also known as isopropanol or rubbing alcohol. We could replace the acetaldehyde with acetone, which is a ketone, meaning a tertiary alcohol will be formed. The methyl group bonds to the carbonyl carbon, and the result is 2-methyl-2-propanol, commonly known as tert-butyl alcohol. As you can see, all of these are larger and more complex organic compounds than the starting materials. If you've never taken organic chemistry, I'm sure this video was really confusing, so thank you for staying with it. If you have, I hope I was able to help you with this concept. If you have suggestions for other organic chemistry concepts to cover, let me know.